Okay, let's see if attendees start filing in. Yes, 3. Hi everyone, welcome. We're just gonna let a few more people trickle in. We'll just give it a few more minutes for everyone to work out their Zoom. All right, I think I'm gonna start at 12:05 just to give everyone a chance to work out Zoom. I know my mom kind of wants to attend. Gotta give everyone a chance to work things out here. All right, I think I'm just gonna go ahead and get started. Thank you everyone for coming out. This is Rasmus's first Earth Week celebration. And this is through the Marine Science Student Organization, also known as MSGSO. We have a sustainability initiative and some really great people known as, I'm calling them my eco warriors. We all came together to put this Earth Week for everyone throughout the community. So thank you for attending. Based on the screen, I just want to remind you that this is a respectful, positive community experience, aka this is a no troll zone. So anyone that is showing any disrespect will be immediately removed without warning. Okay. So with that being said, let's kick off Earth Week, and enough more. I am the first speaker, and my talk is on climate change and sustainability. So a little bit about me. I am a third-year PhD student in atmospheric sciences under Dr. Ben Kurtman at the Rosenstiel School of Marine and Atmospheric Sciences at the University of Miami. So I'm a huge weather nerd at the end of the day, but I also got a degree in environmental resources engineering at the State University of New York, College of Environmental Science and Forestry, and so otherwise known as SUNY ESF. And so that's a little bit of my background with sustainability and earth sciences, and really I just brought this talk together to, you know, marry the two concepts and, you know, be a little bit of educational. So parts of this talk are directed towards earth scientists, but there's a lot of things for everyone to take away from, even if you're not a scientist. So our main goals today are to define sustainability and kind of look at it with a new perspective, and also understand some facts of climate change, okay? Beyond that, I want to highlight the relationship between the two and how they may or may not be relating to society. And again, focusing on earth scientists and obtaining a sense of optimism and purpose through sustainability and climate change. Okay. So what is sustainability, right? So to me, sustainability is one of those words that gets tossed around a lot without people actually really knowing what it may mean, right? So it's hashtag sustainability, or this product is sustainable, or that type of thing. But what does sustainability actually mean? Because it's much more than an environmentalist hippy-dippy concept, right? The actual word sustain means the ability to be maintained at a certain rate or level. So if you're sustaining something, you know, you're sustaining a workout pose, or holding onto something, or sustaining a current rate, right, to sustain. Okay, and so more commonly and applied environmentally is to maintain ecological balance. One way that I like to look at it, and how I personally define sustainability, is through something that's known as the triple bottom line, or through people, profit, and planet, through economic, environmental, and social pillars. Let's talk about this a little bit more, okay? So we have three pillars of sustainability, okay? We have our people, our planet, and our profit. And so the balance of all three of these pillars is sustainability. It is where we have a sustained human ecosystem. Beyond that, to maintain sustainability, we also need equitable, viable, and bearable solutions, right? And this gets even more complex. Beyond our people, planet, and profit, we have a lot of components, and these are just a few that go into our ecosystem, right? So we have things like supply and demand, we have energy renewal, pollution control, technology, social injustices, okay? So all of these things go into our sustained human ecosystem. Beyond that, because we are a system, there are applied stresses. Okay, so one of those stresses, and one that I'm going to talk about today, is climate change. This is a stress, it is a risk, it is a threat to our sustained ecosystem. Okay, even more relevantly, we have a large stress on human health, right? Everyone is very familiar with that right now. And how are we responding? How is our sustained ecosystem responding to this threat, this risk? Well, society and economy are struggling. They're not doing so great. But as you can see, and maybe you've heard, and likely you have, parts of our planet are responding to this, right? So again, a balance. And of course, this is so well known enough that the memes have taken over. So even microscopic might be rebounding. We have dinosaurs in New York, Furbies in the woods, tigers reclaiming their purpose. And of course, rainbow dolphins in the Hudson. So the earth is healing, we are the virus. I don't necessarily agree with that. I do not believe we are the virus. I do think that it is possible. It is very possible for us to live in balance with our economy and our environment as a society, right? And so that's where I want to highlight sustainability isn't a new concept, nor is it a hippy-dippy environmentalist term, okay? To me, it's more of like a lost art. And so to grab onto this idea a little bit more. So growing up, I would always open the fridge, right? And there'd be a Cool Whip container. I'd open the Cool Whip container and it wasn't Cool Whip. It was spaghetti from 2 days ago. So, you know, sustainability is not this new concept. It's really a lost art in practicing less overconsumptive habits. Okay. So this is where we dive into things such as individual impacts, okay? This graph here is showing a bar chart of the emissions reductions from various individual actions. This is a great paper that came out in 2017, and this is CO2 emissions per year per country. So country differences are important as well because our global ecosystem varies by region. And as you may see, certain countries here may consume a lot more than others, and we know this, okay? So the first one here, and while it may be controversial, it is to have one fewer child. Beyond that, there's a lot of other productive things that you can do, and that's living car-free. Doing things as simple as washing your clothes in cold water can be just as effective, if not slightly more, at reducing your CO2 or your carbon footprint individually per year than recycling, right? So I'm not saying that it's good to do trade-offs. Well, I washed my clothes in cold water today, so I don't have to recycle. No. These aren't things that you should be doing trade-offs for. They're small things that you can integrate into your life, right? So maybe you use 3 less plastic items, or you don't eat meat on Mondays. I'm sure a lot of you have heard of Meatless Monday by now, right? Well, then it's like, okay, well, I didn't eat meat on Monday. I don't need to on Tuesday either. And the next thing you know, your meat consumption is significantly less. Another big thing that you can do, and it is highly impactful, is vote. I am not advocating for any particular candidate or for any policy in general, but large-scale changes in policy are going to be needed to make large-scale changes, right? So voting is very important. Beyond this, and maybe coming back a little bit more to like this COVID situation that we're seeing, okay, it's a lot of us are working from home. And you might have also seen that pollution has gone down, air pollution in China, New York, Los Angeles. Well, when this is over, if you continue to work from home 2 times a week, that's a 40% reduction in commuter-related emissions. So if you are commuting to work 5 days a week and you stay home 2 of those weeks, that's a personal 40% reduction in your emissions. That's really easy, especially now that we all have the hang of these Zoom meetings and, having your work from home flow. What is that actually looking like, okay? So this image on the right is from NASA. The source of the article is down here. You can go take a look yourself. It's actually a really cool slider graphic. So the top panel here is NO2 emissions average for March from 2015 through 2019. This is the average for the month of March for these 4 years. Below is March 2020. And while I don't know what's happening in Pittsburgh, I think we still need to do a little work. You can see large reductions from people staying at home because NO2 is emitted from burning of fossil fuels. from cars, buses, trucks, and power plants. And the reason we're looking at NO2 is because it's emitted very quickly, right? So CO2 has a much longer half-life. NO2 is a lot quicker, and it forms reactions a lot quicker, and the life cycle is a lot younger than CO2. Okay, because we can see CO2 in our atmosphere from the 60s, from the Industrial Revolution, it's still up there, right? So whereas NO2 is a lot more immediate. And NO2 further, it in other nitrous oxide compounds mix with chemicals to form acid rain, smog, and also have nutrient deposition on all of our plants. Further, at a societal level beyond our environment, it's affecting humans through our respiratory system, something that's even more relevant right now, okay? So while we are still talking about the atmosphere, let's talk about climate change, okay? So again, everything up here is from NASA. NASA has a great webpage, climate at nasa.gov. They also have a great kids portal. So if you have a lot of, if you're trying to manage your kids at home or you know people that are, NASA has a great climate change kids portal. There's a lot of games on there. I've admittedly played a few, but so this is all from NASA. This is credible information. So let's talk about CO2 now, right? So we saw that the connection of how us taking a step back is related to our emissions in NO2, but now let's look at CO2, because this graph is highlighting back to 800,000 years ago, okay? So we can see natural cycles of our climate, of our atmosphere happening through ice ages, through warm periods, 800,000 years. And then we come onto the stage right here. You can see this is pre-industrial times. This is where we stepped on, 1950, and here we are at current levels. That is really high, okay? So yes, the Earth goes through natural cycles, but we are clearly making an impact here, okay? And we are currently at 413 parts per million. I remember being in high school seeing it was like just over 300 and being like, wow, this is a lot. And you know, how many years later we're already this high? So something to keep in mind. You know, maybe you can work from home twice a week when this is over. So what are some consequences? Okay, so CO2 is a greenhouse gas. And we actually need greenhouse gases, okay? So the sun emits radiation, it passes through our atmosphere, it is absorbed by the earth and re-emitted. That re-emission of solar radiation goes up to the atmosphere and gets trapped by our greenhouse gases, and it makes our planet inhabitable. The problem is, too much of a good thing is a bad thing, right? So instead of having a normal blanket, it's kind of like having a weighted blanket. And what is the result? Increased global temperatures. This is a very simple relationship, but it's what's happening, right? So you can see as soon as we started coming on the stage, we have this increase, okay? And there's further implications of this. Another very simple relationship between the amount of water vapor in our atmosphere and temperature, known to us as the Clausius-Clapeyron relationship, tells us that the atmosphere holds 7% more water vapor for every degree Celsius increase. 7%, okay? So these are some things to start thinking about of where climate change is happening, the direct evidence, and some of the direct consequences. Even further, so we know we've already gone up 1 degree Celsius. There's no turning back from that. And in fact, these projections are showing that between 2030 and 2052, we're probably and very likely to see an increase of 1.5 degrees Celsius. Okay, so this is from the IPCC. This is a very credible source as well. All of these boxes moving forward, these little white boxes with blue text and green border, are from the IPCC. They just had a special report in 2018. They will have another one in 2022. But basically, a ton of scientists get together. They put all their best foots forward and present this, okay? And so a lot of good scientists and science goes behind supporting this globally, okay? And so what we're gonna see is a 1.5 degree warming scenario, guaranteed. Beyond that, depends on our reaction, okay? We do play a role. The amount of greenhouse gases we are emitting is directly related to what our future holds. And that's what this graph is saying. That's what the different colors are saying. Different scenarios based on how we react as a society. Because we know our system. We know our little bubbles and how they overlap each other, right? People, planet, profit, and the stress of climate change on our balanced ecosystem, okay? So our economy, the trade industry, agriculture, habitat loss in our environment, clean air and water, very important. Again, also with society, increased health risk. I don't want to go through this again, and I'm sure a lot of you don't either. These are things to think about, okay? And so again, IPCC stating how climate change is a threat to current sustainable development. Okay, and so here's where I want to take a step back to, because a lot of this can seem a little doomy. Climate change does give people anxiety. It is a low perceived threat. But I want to shift your focus and look at this with a new perspective, right? Because we do have an opportunity, and it's not by looking at each pillar individually. Yes, we all have different values. At the end of the day, what do you worry about? You know, do you worry about the economy? Do you worry about society? Or do you worry about our environment? We all have different values, and that is okay. But where we need to move forward is integrating and overlapping solutions that involve and encompass everyone's values together, okay? And so that key is with integration, integrated sustainable solutions. And so the IPCC and all the top governments are using these things called climate resilient pathways. Okay, so these are strategies, choices, and actions that reduce climate change and its impacts, okay? And so this climate resiliency allows us to adapt and mitigate some of the threats that we are going to be experiencing from climate change. Okay, so these solutions encompass all of our values together. They are sustainable or integrated solutions that make us more resilient together. Okay, so there's two types of pathway responses. There's incremental, and so these are changes that happen to they're expansions of our actions and behaviors already in place. They're almost like business as usual changes, where you are doing small things, right? But these are appropriate in low vulnerable solutions, right? So when something like sea level rise is happening and it's slowly happening, a incremental change might be appropriate where we have time to respond. But the key word here is time, because eventually if we don't make some changes, the only thing that we will be able to do is transformative responses, which then the risk becomes a lot higher. We are now, instead of low vulnerability, we are high vulnerability, right? So now the risk is at our doorstep. It is now a threat, okay? And so now we have to make fundamental changes, okay? So a transformative response is a fundamental change in our system attributes. And that's what this graph over here is highlighting. So in the center, we have a practical transformative response, okay? And so this is when our individual behaviors translate to technical responses, okay? Beyond that is political, and we know this can be difficult, right? So transformative responses aren't easy. And even on a more difficult sphere, personal, and this is more like beliefs and values, worldviews. But if we don't we honestly are running out of time to make incremental changes where transformative responses might be the only thing we have left to respond to climate change. Okay. So one of the things that the United Nations has put forward are Sustainable Development Goals. There's 17 of them, and they look through the lens of 13 of climate action. Okay, and these Sustainable Development Goals encompass all of these things. No poverty, gender equality, clean water and sanitation. That is huge. You know, just because we are able to turn on our faucets and wash our hands doesn't mean everyone is able to. Okay. Responsible consumption and production. All of these items that we can help us become more resilient to climate change need to be realized, and we have to start encompassing them and making responses so that we can become resilient and these things aren't lost. Okay, because if we don't establish a framework to keep our warming under 1.5 or 2 degrees, some of these goals will become virtually impossible to achieve. Okay, and so to look at this a little bit more, we have our climate resilient development pathways, right? And so we do understand that not everyone's the same. If we start making more transformative responses and are able to start achieving nearly all of our sustainable development goals, lower our emissions, limit our warming, and then become more climate resilient, right? So this translates to how we will be responding to stresses in the future, changes that we're making now. Something like COVID was immediate. It happened fairly quickly, and we had to respond very quickly. That's almost like a transformative response. Okay, so if we don't and continue business as usual, our resiliency to stressors such as climate change are going to be way worse. Okay, and that's highlighted even further in the special report that came out in 2018. Without societal transformation and limiting warming to 1.5 degrees, we will have exceedingly difficult, if not impossible, chances of achieving sustainable development, okay, or becoming resilient as a globe to climate change. So that is powerful, but I also want to switch my focus a little bit to all of the scientists in the room, because as scientists, especially earth scientists, we have a unique opportunity to make some serious impact. We are in a great position because we are the ones that study these systems. We understand them. And I don't know about you, but I want to protect the things that I study, the things that drive my curiosity, the things that drive my passion. Okay, and so we have the opportunity to make impact, okay? Make our science count, get people to pay attention. Why should people care about your research? And then further than that, communicating it effectively, being a credible source, putting your best science foot forward. In addition to that, even doing outreach, okay? You're in a unique position. And even further, to become a leader, lead by example, becoming aware of your own habits, because as earth scientists, why should we expect others to pay attention to the impacts of climate change if we're not even paying attention ourselves? So example, I'm going to call out all the climate scientists in the room. How should we expect people to respond to our research if we're not even paying attention to how we're changing the climate ourselves? Okay, so being a leader, setting examples for everyone, as well as putting our best science foot forward. Okay, and I would just like to end on this kind of fun note, especially because it's Earth Week. Awareness starts with one, okay? And again, doing small changes, putting your best foot forward, that's what matters. Okay, some of my sources, and that's it. Thank you everyone for joining our Earth Week. I'll take any questions. Just a few. We have another speaker. Nope. Okay. Check. Cool. Alrighty, so with that, I'm going to go ahead and stop sharing my screen and introduce our next sustainable queen. She is a really great scientist, as well as someone who engages a lot with the community. Rumya, you can go ahead and take over from here. Thank you, everyone.
Thank you, Kayla. Good job. Let me share my screen real quick. Just a second, my computer is being weird. Okay, got it. Share. Okay, so before I begin, a little bit about myself. My name is Rumya. I am a current PhD student at the University of Miami, Rosenstiel School. I also work for the Key Biscayne Community Foundation as their citizen science coordinator. I'm basically in charge of their citizen science program. So I noticed that a few questions just came in for Kayla. We'll address those at the end. I'll try to get through with enough time to address those, or so Kayla can address those. A little bit about myself. I've had a million jobs, many of them environmentally related. I have experience both working in the field and in government. I also was the office manager in a law firm, and that only matters because this fall I hope to apply for law school, so I'd be doing a joint PhD JD program in environmental law and ecosystem science and policy. I have a bachelor's in biological sciences and an MPS in fisheries management and conservation. I have another bachelor's in arts in sculpture, which is not relevant, but is fun. And so as far as government work, I've worked as a biological science technician for Army Corps of Engineers, and I've also was a White House intern with the White House Council on Environmental Quality, and I specifically worked with the National Ocean Council. And a lot of that has actually sort of played into my PhD research. So what I'm going to talk to you about today is environmental sustainability and community awareness. I'm going to kind of go over what I'm doing for my PhD research and why that's sort of community-based, or like, you know, the sort of larger impact of that. And then also what I do for the Key Biscayne Community Foundation for community education and awareness. So, as I said, so first I'm going to go over my PhD research very quickly, and then we'll talk about environmental education, and then community awareness and action, and the things that we are doing on Key Biscayne, and somewhat broader than Key Biscayne, but mostly it's localized to Key Biscayne. So my PhD research is specifically looking at pharmaceuticals in marine environments and how they affect those environments. So I'm specifically going to be looking at estrogen and SSRIs, which are antidepressants, in combination with each other and how they affect marine fish. Right now I'm working with toadfish. I will hopefully be working with sharks also in the future. Different ways pharmaceuticals enter the marine environment. Majority is through sewage. People flush them down the toilet. They go through the body unmetabolized a lot of times, and then eventually make their way out to the ocean. The majority of it comes from households. However, there are hundreds of millions of tons that are flushed from healthcare facilities such as nursing homes and hospitals and places like that. You also get it from other areas such as agriculture, where farmers are giving hormones to their cows or something like that. And then they excrete that, and eventually that gets washed by rainwater into river systems or streams, and that makes its way out to the ocean also. So there are a number of different ways, and that's only some. There's also like landfill seepage and things like that. There are a number of ways that pharmaceuticals can make their way into the ocean. And there's been a lot of studies to see how they affect aquatic life. What they found individually, the majority of the studies that have been done have specifically looked at usually one type of pharmaceutical. So you would look at just antidepressants, and maybe several different antidepressants, but just antidepressants or just endocrine disruptors or antibiotics or something like that. And what they found is that any number of these types of drugs can influence behavior, physiology, development of animals, and often the survival of many different aquatic organisms. This is what I was talking about a minute ago. This is just a sort of a drawing showing how different ways PPCPs, which are personal care pharmaceuticals and personal care products, how they get into the water. So, industries, hospital, households, landfills, all kinds of different ways they get into the water. That can get into drinking water and then affect people. There's also, as I said, an ecological risk, how they can affect the aquatic environments. My research, as I said, looks specifically at marine environments, but it definitely has been shown to affect freshwater environments also. So one of the things that we plan on doing is environmental testing. So to see what the concentrations are in various areas close to wastewater outflows. So as I said, pharmaceuticals can enter the environment in various ways, but also in different formats. So you'll have the actual full molecule of an antidepressant, for instance, or it might have broken down into certain components of that molecule, that antidepressant molecule, and those components themselves can also have their own effects. Sometimes you also find that there are pharmaceutical mimicking compounds. A really good example of that has been found recently is plastic. As plastic photodegrades in the environment, some of those compounds have pharmaceutical mimicking compounds. And what happens is that a lot of times is they mimic endocrine disruptors like estrogen or something like that basically hormones. And that causes all kinds of different problems, such as spawning issues or developmental issues where you need like estrogen to develop female or testosterone to develop male in certain ways, or a balance between the two, obviously. One of the research projects I worked on a long time ago in Northern Indiana, I was a fisheries biologist there. And we were finding in one of the rivers that we were sampling that the freshwater bass, the male bass in particular, were developing what we called ovotestes. And basically what it was that their testes were changing into ovaries. These were full grown adults, but their testes were changing to ovaries. And basically what that did was just make them completely infertile. Like they couldn't produce eggs or sperm at that point, or, spawn properly. And we found out that it was because of the high levels of estrogen that was found in that particular river. And all of that came from the wastewater treatment plants. So it was coming from people doing, flushing it down the toilet, or just, in their waste, or, these various sources. And the most interesting thing, which is my second point on this slide, is that these like adverse effects can happen at extremely tiny concentrations. So for those of you, most of you, I assume, are scientists, if you're talking about things in 10 to the minus 5 or 10 to the minus 6, those are extremely, extremely small concentrations, but that is enough to cause detrimental effects. Another study that I did, unfortunately I didn't include a slide for that, was on freshwater bugs, basically, again in Northern Indiana. So we tested on mosquito larvae, Daphnia, and freshwater hydra. And we were testing antidepressants in 10 to the minus 6, I believe. And basically the hydra and Daphnia just died very quickly. And mosquito larvae did not die because, you know, they're mosquitoes, so why would they? They're like cockroaches. But they changed their behavior. So if anybody, if I'm sure all of you, from, you know, being from Florida, if you hit stagnant water that has mosquito larvae in it, they just start flipping around and freaking out. And that's their flight response. And what we found was that the presence of antidepressants, while it didn't kill them, it changed their response. They would just kind of swim off smoothly, just kind of move. And that's really more their feeding behavior. So they lost their flight response, essentially, their fight or flight response. And so most of the studies that have been done so far are specifically to one type of pharmaceutical. So you're looking at just, as I said earlier, just antidepressants or just antibiotics or whatever. So what I'm planning on doing is a combination study. Somebody just asked for my email. My email is at the end of my presentation. So it'll be there. So yeah, as I said, the current research is going to focus on the two different types. We're going to do a combination study to see if there's, because obviously in nature with everything that gets dumped into the water, they're going to be exposed to multiple types of pharmaceuticals at once. And so that's what we're going to test, at least 2 different types of pharmaceuticals. As I mentioned, that there have been a lot of different detrimental effects. Fish larvae, estrogen has been shown to cause developmental problems in male gonad development, or even not even just development, just like, as I said, in full grown males even, it causes changes within their body. You have a reduction in the number of eggs a female can lay if they're exposed to too much estrogen, and a number of other things. There's a myriad of different effects. And SSRIs, or antidepressants, they can cause lethal toxicity, behavioral changes, as I mentioned earlier, and those were in the freshwater bugs. But they can also create anxiety in the animals that, you know, and most animals, especially if they're prey animals, like they already have a very heightened sense of anxiety. And so causing that to increase will overload their systems, or it can. So, and then you have, like I said, changes in behavior. So antidepressants can create increased anxiety. It can also relax them too much. One study I read about shrimp, most crustaceans are nocturnal. They only come out at night because everything eats them. And what they found with shrimp is that they would come out during the daytime because they lost their fear because of the presence of SSRIs. And obviously that's, you know, very detrimental to their survival. So as I said, right now we're going to be testing on toadfish. We're hoping to also be able, not test on sharks specifically, but gather tissue samples from sharks and test them to see what types of not antidepressants, but pharmaceuticals they've been exposed to. So then we're also going to look at the social perception of that. As Kayla said, you have to sort of take a more integrated approach to a lot of these things. So we're going to look at how people sort of approach these ideas and what they think. There are most of the studies that we've looked at show that there are not any effects to humans as far as like if they're eating fish that have been exposed to these types of pharmaceuticals or anything like that, because the concentrations are so low. It's enough to affect the fish's brain chemistry, but not enough to affect a person. You'd have to eat like 85 pounds of fish to get like a single dose. However, we don't know what the longer term effects of these are. Some of these medications are made to sort of bioaccumulate in your head. And so that's what they do to various animals in the ocean. But we don't know, like, when you're getting like a combination of things and some of them bioaccumulate, what the long-term effects are on humans. And I already mentioned that most of them are flushed down the toilet. So these are just some of the questions that we're going to look at as far as, you know, people go, like, how do they, like, what do they know about pharmaceuticals in the environment? The average person doesn't really know anything about it. They might know about sewage, especially around Key Biscayne, because we've had beach closures repeatedly due to, you know, sewage bacteria and things like that showing up. But they don't know that within that could be, sorry, my cat's being annoying. they don't know that within that there can also be these other things like pharmaceuticals. And one of the ways when they test to see where this bacteria is coming from, to find out if it's coming from human sewage, they specifically will test for pharmaceuticals. The presence of pharmaceuticals will indicate that this bacteria has come from human sewage, which means that there's a sewage leak. So that's just kind of an interesting factoid. You know, and then we want to know like how the public worries about their seafood supply, or do they have any preconceived notions? You know, there's a lot of things that we want to know about, like the social concerns about this, whether or not they're warranted. A lot of these concerns are swayed by the news cycle also. So that's something to take into consideration. So we did a pilot study in Key Biscayne just to find out what it was people were worried about. And obviously this was right during the time when we had like, I don't know, 15 beach closures in 1 year or something. So everybody was concerned about sewage. That's what everybody was concentrating on because they assumed that this bacteria was coming from sewage. But they don't realize that within sewage, you're gonna get pharmaceuticals. And so the concern for pharmaceuticals was actually considerably lower, even though if it was a sewage leak causing these beach closures because of bacteria, then you're gonna find the pharmaceuticals also. And a lot of these other things that I have listed here would also be found in sewage, except for maybe fertilizers. So moving on, so that's my PhD research. As I said, I also work as the citizen science coordinator for the Key Biscayne Community Foundation. And I'm going to quickly sort of go over the sorts of community activities and education that we do in order to engage people in, you know, awareness and understanding why taking care of the environment and sustainability is important. Thankfully, Kayla covered quite a lot of this already, so I'm going to try not to repeat too much of what she said. The mission of the Key Biscayne Citizen Science Project is to have citizen and professional scientists monitor and protect resources and to share information on the most critical natural resources of Key Biscayne and Virginia Key. Now, this is an old mission statement. Recently, we've been talking about the possibility of expanding outside of Key Biscayne because the program has grown quite a bit in the last like 2 or 3 years. We have a number of partners that we work with, and this is one of the most important things when it comes to community outreach, is being able to reach as many people as possible so that you can educate as many people as possible. So we try to partner with all the schools, different environmental organizations. Obviously, University of Miami is a huge partner of ours. And then different organizations on Key Biscayne also. The programs that we have that promote environmental awareness include the Key Challenge, which is based on the Fairchild Challenge. And I'll talk a little bit more about it later, but it's essentially an extended science fair that goes throughout the year where the kids, all the schools on the Key plus Mast Academy, which is right across the street from Rasmus, they participate in creating environmentally oriented projects. And each year we have a new theme, and we keep the theme broad so that we want the kids to sort of like, you know, use their imaginative juices to come up with interesting projects. Like 1 year we had human impact, which, you know, could be anything or everything. So those are, you know, some of the things that we do that every single year. We have this project. Right now it's on hold because of the pandemic, but normally we have it every year. We've done water testing. Again, this goes back to the bacteria problems that we've had with beach closures. So we sponsor water testing throughout the Key. We sponsor beach cleanups. We have environmental workshops, restoration projects. In particular, we have worked with in the past Rescue a Reef, which is the nonprofit that started from Rasmus. And some of our efforts have been delayed because Hurricane Irma ruined their nurseries, but we hope to continue working with them in the future to keep outplanting corals. We have monthly lectures, citizen science lectures. We call them citizen science lectures, but they're basically anything science related, just to teach the general public about different issues that, you know, are facing not just the Key, some of them are worldwide issues. We have a community newsletter that goes out that talks about all of our initiatives. We have a butterfly garden that we've planted on Key Biscayne, and we have it maintained by students and volunteers. And every now and then we have talks about it to explain why butterfly gardens are important. again, you know, saving butterflies in the world is a very minor thing when you're talking about large scale problems like climate change, as Kayla was talking about. But it's important to remember that like every little bit helps. Every small thing that you can do is helpful. And you want to keep trying to get everyone engaged, because even if they just start with little things like this, that can then kind of balloon into something bigger, a larger movement, more people, things like that. The youth fishing clinics that we have in the summer specifically teach kids about proper techniques in fishing, how to get rid of fishing gear without it ending up in the ocean, and you know, proper catch and release techniques, things like that. So some of the lectures that we've had, these are just examples. As I said, coral restoration. This was a lecture that we've had some of them from Rescue a Reef. We've had other ones, and I see that restoration is spelled wrong. That's awesome. But anyway, so we just talk about these different projects for coral restoration and other types of restoration projects. Plastic, we've had several lectures that are about plastic pollution. This is a picture at the bottom here from one of them that talks about plastic production and how that's changed over the years. And you can see a huge spike, obviously, from the 1960s to 2000, this goes to 2014. And, you know, production of plastic is a huge problem. It's a petroleum product, so you're using more oil, which is bad for not just the environment, but also the CO2 levels. It's a non-renewable resource, and plastic doesn't biodegrade. It's, you know, it stays there forever, and it like chokes everything out, and, you know, is obviously terrible for the environment. Plankton Portal was one of my favorite lectures, so I had to put in a slide about it. It was literally just teaching people about plankton, which sounds really boring, but was actually very interesting. In particular, this was good for citizen scientists because they ended up with came up with a method of photographing plankton that was so, like, they were so good at it, basically, that they ended up with something like, I think, 11 million photos in a short amount of time. And there was no way that the research team, and this was a research team from Erasmus also, by the way, out of CMUS, I believe. But, you know, they were so efficient at photographing plankton, there was no way they were going to be able to get through their photos in any reasonable amount of time. So online, there is a website called Zooniverse, Zooniverse, zooniverse.com. And scientists can upload their pictures from their research projects and have citizens and give like tutorials on like what it is they're looking for within these pictures, and have citizen scientists come on to their, you know, pick a project to work on and then help them get through their photos. And in fact, one of their one of the citizen scientists that logged into Plankton Portal and helped identify species of plankton did so many photographs just by herself that they gave her a shout out in their publication. I don't think she was an author, but she got a shout out because she did so many and became really good at it. I mean, obviously, the more you do, the better you are able to do it. And, you know, it's a really good way to get people engaged. And while this isn't specifically about sustainability, getting people to show concern and learn about their environment makes them more likely to live sustainable lives, because they've learned about it and now they care about it. And that's really one of the most important things. And that's where you get the idea of awareness. And so once you're aware of what there is in your environment and how important that is, then you are more likely to work to live a more sustainable life, do whatever you can to help. And then also, you know, in some cases anyway, like change the minds of your friends and family to also do the same. And then this was another lecture about, you know, a few different ones about plastic pollution. And that obviously is a glass bottle, Corona bottle there, that's not plastic, but there is a hermit crab that has grown up inside of it and could not get out. They did break that open and get him out. I don't know how he was alive. So the key challenge, as I said, is an island-wide initiative that goes with all of the schools on the Key. And we've had at least 1,200 students participate. Every year our participation grows. And we have, you know, environmentally relevant ideas or themes that we work on. And we did get a grant from the EPA also for environmental education that went towards this, that made us able to grow it quite a lot more in the last few years. The trophies that we give out at the end after the judging are made by a very good friend of mine and colleague named Nate Moyer. He's actually our web designer, but he also created a nonprofit called Free Plastic. And he creates amazing artwork and furniture and other things out of recycled ocean plastic. And so our trophies are made from recycled ocean plastic. The pictures that you see here are actually from the photography contest of the Key Challenge. The one on the bottom was taken by an 8th grader, and I think he won first prize for that. He was trying to show the contrast between like the industrial side of Miami and like the natural side. And the top one was taken by a 2nd grader, I believe. She also won first place for her age group. These are also some other photographs that the kids have taken. The one on the bottom was taken by a 1st grader, which is incredible. And that was actually just human impact. That was the theme for that year. And I think that's a really good demonstration of human impact. Obviously, the top one is a really good example of climate change. That's a king tide on Key Biscayne. And they are having fun surfing on their street. And then, you know, just wildlife. And this doesn't show any effects of these, you know, plastic or any other like human impacts on wildlife, but it is important for them to also learn about like the native wildlife and why they're important to having an ecological balance. And then these are just some pictures of some of the kids getting their awards, and there's some terrible picture of me. And you know, they get really excited about it. And to get kids that young, this excited in the environment will, you know, hopefully push towards growing more eco warriors, as Kayla put it, in the future. These are some pictures of people doing a beach cleanup. This is on Bill Bags. We sponsor those beach cleanups. And these were pictures from the first coral restoration with Rescue Reef that we did. It was in 2017. And the picture on each of these, the picture on the left shows the initial outplant, and then the picture on the right shows a year or two later how those corals have grown. So basically, and I think I read this quote somewhere, but I couldn't place it. It's important to know that the Earth is going to survive without us, but we cannot survive without the Earth. The efforts that we put in now are basically for our own benefit, so that we have a place to live that's habitable. We have to be able to stay here. And if we continue on the path that we're on right now without making any changes, we won't be able to live in the environment that we're creating. So it's not just about like, you know, a lot of people like to say save the Earth, but it's not really about saving the Earth. It's about saving us and making sure that we live in a place that is balanced. You know, the ecosystem is balanced. We can survive here, and it works for everybody and everything that exists on Earth. There's some of my sources, and there's my email address for the person that asked for that. And I can take any questions. Kayla, it looks like most of the questions are for you. I'll stop sharing my screen here.
Hi, yes, thank you guys. Thank you everyone for coming to our first Earth Week event, our first set of talks. I hope they were engaging enough that you guys want to come back for more or even attend some of our evening events. Regarding some of the questions, thank you guys for coming. Lori, you had a great question regarding sustainability, tourism, travel, our role as scientists in going to conferences. That's a really good, challenging question, right? And so this borders that line of where are we willing to make a sacrifice in our own lives, right? So yeah, taking flights and going places to learn more as part of our career, especially as climate scientists, that's been a hot topic. However, I have yet to form an opinion on this. So that is a good challenging question, right? So as a grad student, my options, as a grad student that doesn't have a car, right? I just went to a conference in Boston. And so in terms of time and resources for me personally, my best option was to fly there, okay? And that is a little bit controversial as a climate scientist, yes. But becoming realistic in the impacts that you can make individually is very important, right? Because becoming an all organic vegan that is able to eat really nice organic food might not be appropriate for a low income family that's just trying to put food on the table, right? So it's also about personal resource and availability, right? So sustainability is also viable, bearable, and feasible solutions. So it really comes down to the individual on something like that and doing what you can when you can. Rumya, if you want to answer a question.
Sure. Let's see. Oh, so the reason that we were working with toadfish right now is just because of availability. The lab that I work in specifically has a supply of toadfish, so it's just much easier to work with them. But they also make a really interesting study subject because they are extremely hardy fish. It is really hard to kill them. A good example is I had one out of the tank a couple of weeks ago because he got infested with sea lice, which is a thing and it's disgusting. But I took him out of the tank and I was plucking them off. I anesthetized him so that he, it wouldn't bother him. But the thing is, they can breathe air. So as I was holding him out, he's slowly breathing air, and his sleeping or whatever, it started wearing off, and he woke up and I had him out of the water for half an hour, and he woke up and started flapping around and freaking out. Like, they are really hardy fish. So it's really interesting to show, like, when you're testing with them, if they are susceptible to something that you're exposing them to, then you can make an educated guess about how that then affects more sensitive fish that live in the same environment. And toadfish are very common all over Florida. So they share their environment with lots and lots of other organisms. So it's a really good way to, without having to expose more sensitive fish that die easily in captivity or something like that, to show that, or to make an educated guess about how these other more sensitive organisms would be affected. So change in coral coverage. Yeah, so probably the only reason the water looked cloudier is either a change in weather conditions. It might have been, the waves may have been worse that day. It's also possible that the scuba diver that took the picture had kicked up some sand or something like that. But chances are the water quality difference from one day to the next is not going to be, or from, from the first picture to the next picture, which is, years apart, it's not going to be a huge difference, at least not as far as turbidity like that. So probably it just had to do with wind or the scuba diver themselves kicking up some kind of sand. And I do teach undergraduates right now. It's for a class for my PhD. Although that's a field techniques course that is not really about marine science. But we do take interns at the foundation every so often. Every now and then I'll reach out to Rasmus looking for interns. Right now we're not taking any just because obviously everybody's working from home and it would be too difficult to train one. But we do take interns every now and then. And sometimes they, as young as high school. But yeah, I mean, we love to have people involved as much as we can. So we do try to reach out. I mean, obviously my entire job is reaching out to the community. But yeah, we do like to have interns and have people working with us that can learn anything from us. And no, we have not looked at how pharmaceuticals have impacted coral. I think there are a few studies about it. But because I'm specifically focusing on vertebrates, I haven't, at least for my PhD study, I haven't looked at how they, the pharmaceuticals can impact coral. That would be a really interesting area to look at. We know that coral gets very sensitive about temperature changes and, you know, changes in water quality and stuff like that. So I can only imagine that being exposed to a pharmaceutical would also affect them. But I am not a coral scientist. I don't know enough about corals. I'm a fisheries person. So, but that would be a really interesting area of study. And if I could find somebody else who was doing that, I would definitely want to address that or do some kind of joint study if that was at all possible.
Awesome. Thank you, Ramya. There's one question remaining from John, who's a non-scientist planning more to write about climate change. He's wondering if there's a copy of our presentations, and the answer is yes. So any of our Earth Week events will be available on YouTube post Earth Week for you guys to go back and revisit whenever you want. It will be on the Rosenstiel YouTube page. Also past Earth Week, it will be up on the website where you found potentially your Zoom link. So earthweek@rasmus.com. So yeah, thank you everyone for attending, and I hope to see some of you at more of our events later. Happy Earth Week.